Welcome back, friends. In the previous sessions, we were dealing with geometric progressions, and before that, we were dealing with progression, sequence, series, different types of progression, arithmetic progression, sum of n terms in arithmetic progression, its different activities, cases relating to arithmetic progression, followed by arithmetic mean, its different cases related to arithmetic mean. After that, we dealt with geometric progression. We all know what is meant by geometric progression, its concept. Sum of n terms in geometric progression. There are three equations. Make aware about all these three equations and when to apply this equation. Let's deal with some of the important cases relating to geometric progression. Find the value of 0.6666. You need to take the sum of n terms of a geometric progression. And as we all know, till last class, we have dealt with the cases or sequence or series in which you will be given a series of number or a sequence of number which has a regular interval of or common ratio of a certain specific number, and we know how to deal with cases when the r is greater than 1 or r is less than 1 or if the series is an infinite. We all know all these cases. But here the question is that you need to find the value or sum of 0.66666. How we are going to do it? And it's not ending. It's going on like that, 0.66666 and something like infinite case. And we know how to deal with geometric progression cases with the infinite situation. But in order to apply that, you need A as well as R. Here there is no details regarding A and R. So whenever this situation or whenever you deal with such cases, you need to understand that here this number 0.666 and infinitely goes on like that. In order to get that number, you need to follow this concept. Here it can be computed by adding 0.6 plus 0.06 plus 0.006 plus 0.0006. Likewise, it goes on like that until there is an end. Since there is no end, we can consider that it is a case of infinite seriality. So from the analysis, we found that here A is 0.6 and R is 0.06 divided by 0.6 equal to 0.1. By substituting the same in the infinite equation, in geometric progression where sum of n terms is geometric progression in which when the scenario is an infinite situation, a substitution of n equal to A divided by 1 minus R equal. Here the value of A, that is 0.6 divided by 1 minus R, the value of R is 0.1, that is 0.6 divided by 1 minus R equal to 2 by 3. This is how when a situation like this comes, you need to do it. Next case. Find the sum of the geometric series number 9, 3, 1 goes on like that till 1 by 6561. How we are going to deal with that number or that case? Okay, let's note down the known values or expand the data given in the question. Here A is 9, that is 9 is the number starting in the series. Okay, and R is 3 by 9, second number divided by first number, you will get 1 by 3. Note that R is 1 by 3. As per the rule, R is less than 3, you need to take that specific equation. Okay, in the question it is given An equal to 1 by 6561 and N. Okay, here N is unknown. And we know that it is a case of second equation where R is less than 1. So before going into equation, understand that here the value of N is unknown. So without N, you can't apply that the same in the equation. So first of all, you need to find the value of N. So let's find the value of N. Once we get the value of N, you can go for that equation. We know that equation of geometric progression case is Tn equal to AR raised to N minus 1. That is Tn equal to 1 by 6561 equal to 9. A is 9 into R. R we know that 1 by 3. 1 by 3 raised to N minus 1. You will get. Okay. since here the equation is in the form of 1 by 6 by 6 1 equal to 9 into 1 by 3 raised to n minus 1. Let's multiply this with 6 by 6 1 and you will get 1 by 59049 equal 1 by 3 into n minus 1. I hope you are aware about this situation or step 1 by 6561 equal to 9. How we got 1 by 59049. It is as per the basic mathematical step. You are aware about it. So let's go with the further cases. Okay. 1 by 59049 equal to 1 by 3 n raised to n minus 1. We have dealt the same situation in the previous slide. So whenever the case or whenever you come across a step or situation like this, you need to take the exponential form of the highest number like this one, 59049. So by taking the exponential form of 59049, you will get that by factorizing 10 times you will get this product 59049. So on the basis of exponential form computation, you get that 1 by 3 raised to 10 equal 1 by 3 raised to n minus 1. From this point onwards, we have dealt the same situation in one of the previous slide. Just refer to it or let's go on with it. Here, by removing this both fraction from the both side 1 by 3 and 1 by 3 from left and right of the equal sign, 10 equal to n minus 1, that is n equal to 11. Now we got n, a, r and a. Let's substitute the same in the equation. Since the r is less than 1, we all know it less than 1, so we use the equation, second equation as per the slide. By substituting the same in that equation, you will get 9 into 1 minus r raised to n divided by 1 by r. I hope you are all familiar with the equation. I just substituted the same equal, you will get 9 into 1 minus 1 divided by 177147. This is obtained by multiplying 1 by 3 11 times. That's how you got this number. Divided by 1 minus 1 by 2 by taking the factor and cross multiplying the 3 with 1 and 3 minus 1, you will get 2 by 3. By solving this, you will get 177146 divided by 19683 divided by 2 by 3. You get S subscript of 11 equal 8.9999492 divided by 0.6667. Finally, you get 13.4992. Okay, let's deal with some other cases. Show that the sum to n terms of the series 11 plus 103 plus 1005 plus a series is going on till 10 by 9 bracket 10 raised to n minus 1 bracket close plus n2. So you need to take the sum of the series, and its series looks similar, but the ending is somewhat complicated. So let's see how we are going to deal with it. Here s equal to or s subscript of n equal to 11 plus 103 plus 105 1005 plus it's going on like that. So whenever this situation comes, see 11 plus 103 plus 1005, it doesn't look a geometric progression case, or if you go for common ratio, you will not get a number. So whenever this situation comes, you need to make some alteration in the series like this. S of subscript of n equal, in order to write 11, you just split the number into like this 10 plus 1. Again, in case of 103, you split it like 10 raised to 2 plus 3, or it will mean that 100 plus 3. again plus 1005, you can write 10 raised to 3 plus 5 or 1000 plus 5. 10 raised to 3, the other meaning is 1000, is 10 into 10 into 10. Okay. Next step, you need to split the numbers within the bracket into two categories. That is, in the first part, 10, first number of each bracket has to be taken in the under first part. That is 10, 10 raised to 2, 10 raised to 3. You need to write all these first numbers in the first brackets as in the first series. That is 10 plus 10 raised to 2 plus 10 raised to 3 plus the series is going on plus. In the second bracket, you need to add the numbers in this series where those numbers that are second in those brackets, that is 1, 3, 5, that is 1 plus 3 plus 5. Now the series look similar, that is this one, that is 10 plus 10 raised to 2 means 100, 10 raised to 3 means 1000. This looks like a geometric progression case. Whereas 1 plus 3 plus 5 plus series, that looks like an arithmetic progression case. So students, be cautious. Whenever the situation comes, means whenever a question or series is asked to find sum more or whatever it is, whenever you think that the series is not a common, doesn't have the common features of any of the series or progressions, just split the entire series into something more meaningful and understandable and easy to be computable as per geometric progression or arithmetic progression cases. Okay, here in the first part of the series looks like geometric progression. And one more thing, you don't have to write 10 raised to 2. Instead of 10 raised to 2, you can write 100. And 10 raised to 3, you can write 1000. This is depending upon your discretion. Okay, the first part of the series is in geometric progression. This one. And second part of the series is arithmetic progression. And the question was that you need to find the sum. We know the sum of, how to take the sum of n number of items in geometric progression as well as arithmetic progression. So on the basis of that, you need to extract what is meant by a, n, r in case of geometric progression and a, d, n in case of arithmetic progression. So we know the equation to find the sum of n terms in geometric progression. Here a raised to r raised to n minus 1 divided by r minus 1. You know why we took this equation, because here the r is 10. That is 10 raised to 2 is 100. 100 divided by 10, you will get 10. So r is greater than 1, so we selected first equation. And for arithmetic progression, the equation is sum of n equal to n by 2 into 2a plus 2a into n minus 1 into d. By substituting the known values from the cases, we will get s equal a subscript of n. You need to add n. Okay, a subscript of n equal a, that is 10 into r. R we know 10, 10 raised to n minus 1 divided by this division, divided by r minus 1, where r is 10, so 10 minus 1 plus. Don't forget to put this plus, because our series, look at the series here, first part of the series, after that there is a plus sign, followed by plus sign, you have another series, so don't forget to put plus. Okay, plus n by 2, we don't know n, so n divided by 2 into 2a. Here a is 1, so 2 into 1 plus n minus 1 into d. You know how to take d. Here d is 2. By solving this, you will get 10 by 9. Here this 9 is obtained by solving this one, 10 minus 1. That is why 10 by 9 into 10 raised to n minus 1 plus n by 2. 2 into 1 is 2 plus 2n minus 2. That is, here the 2 open this 2n minus 1 bracket. So you will get 2n minus 2. By solving this, you will get 10 by 9 into 10 raised to n minus 1 plus n square. See, the question was that show the sum of to the n terms of the series 11, 103, 105 plus, that is, you will get 10 by 9 into 10 raised to n minus 1 plus n2. We finally got the answer. Okay, next one. It's a known, just remember it, when the product is known, That is, when the product of a series is known, three numbers in geometry progression can be taken as a by r, a and ar. There are a number of notes which we have discussed in the previous session. Just remember all these notes. We will deal with this case in the next session.